So we start talking about this one. So I hope you can derive the equation of trajectory by yourself, or not. You may. I hope you are able to memorize it. So otherwise, it's too hard for me to derive it uh, again and again. So it's my pointer. Yeah. Mhm. Sorry, it's the problem with my drawing pad. It sometimes connect, but sometimes does not connect. Okay, so the equation is y due to tangent theta x minus gx squared over 2 u squared. And then we are using a ugly form. So minus gx squared over 2u squared tangent square theta. So what does it mean by this ugly form? So this ugly form, if you still remember, this is a quadratic equation of x and also the tangent theta. So then we will make use of this one to do it. So then how can we do it? So this is the region. So if you consider it as a missile, okay, missile launcher, and then so these are the region where the missile can hit. So these are the region that the missile cannot hit. So mathematically, what does it mean by this region? So this region, it means that, okay, because the missile can launch at different angle, and then in this region, that means any point. So let's say this point. So that means you can find the launching angle. Okay, you can find the angle theta, and such that the missile can hit this point. So if this point, so that means there's no angle for the missile to be launched to hit this point. So mathematical speaking, okay, so this region, that means the region where there are a solution of tangent theta. Okay, there is a solution of tangent theta. For this region, there's no solution of tangent theta. So what does it mean? So that means the discriminant should be greater or equal to zero for the region of the envelope of safety. Understand? No? Yes, no? If no question, then let's go on. So, then how we can solve it? Be reminded that for using the discriminant, you should have the form that is ax squared plus bx plus c equal to 0. So don't omit the y on the left hand side. So you need to make the y be on. So you need to make one side of the equation to be 0. So what I would do it like I would put everything on the left hand side. Be aware that uh, the variable is not x here. Okay, the variable is tangent theta because we want to have a real solution of tangent theta. Okay, I hope you still remember this one. So this is b squared minus 4ac. So b squared is x squared, and then minus 4a and c greater or equal to 0. And then what you need to do next is just to simplify this formula. Then you can get the equation of envelope. That's it. I don't remember the form, but you can do it by yourself. Okay, maybe June you do it now, and you send me the answer. Okay, or the others. Okay, you also do it now and see if you can all get the same answer. I'm still trying my character. You send me in WhatsApp. That's easy, I think. Simplify. Well, so what do I mean is just make y be a subject of the equation. So there's a code. Y. So you delete the what you can do first is delete the x on the left on the both side. I need to use this result because I need to do the next question. I need to use this result. And then next thing is uh, expand the bracket here. Or maybe you multiple by okay two u square over 2g. Then you can get the result, is it? The funny thing behind is that this equation is still a quadratic equation. Can you see it? It's still a quadratic equation of x squared. So it still follow a parabolic path, but it's concave downwards. So this is the shape of the parabolic envelope. So you need to know how to derive it from this equation. Okay. So that's why I asked you to memorize this equation. Otherwise, if you can't derive this equation, then you can't do this question. Okay. This question, the trick is these are the region that you can find the angle to hit the point or to hit any point in this region. So that means there is a solution of theta. Then that means there's a solution of tangent theta. And if there's a solution of tangent theta, then that means you can use the discriminant to solve it. Okay? I think I need to move the see, character a little bit. I think this may be better, is it? It seems better. Haha. 好啦. So let's go to the next one. So next one is a more difficult question. I recommend you to memorize the answer. So in most of the case, the question will use the numbers instead of a unknown. So this is a question. So there is a particle, okay, and then you are hit. You are uh, throwing an object from this point, and then you want to hit this point, okay, hit this point, and then you want to find the minimum speed that is needed. Be aware that when the speed is minimum, it doesn't mean that the speed at the highest point is horizontal. There's no any consequence between these two. Okay, and we are going to use this formula again. Use this formula again, but actually using similar formula. So what we can do is now we substitute the s and h in the equation of trajectory first. So what you get is x equal to s tangent theta and then minus g s squared over 2u squared. Why is moving when I'm writing? The computer is so annoying today. And then minus gs squared over 2u squared tangent square theta. I think it's better now. And then we say that there is a real solution of tangent theta. So we are doing something similar, okay? So that means actually we want to hit this point, so that means you can find the angle to hit this point. And then that means we still have the same result from this one. So that means I just want to copy it down. So actually it's more than u square over 2g, and then minus gs square over 2u square. Now, this inequality seems very difficult to solve. Yeah. So what I do first is just to multiply by 2g on both sides. Okay. And then I minus multiple by u square again. Okay, and then I make everything on one side. So next, what I will do is to complete the square. Complete the square. Okay. Then I think you are able to make u be a subject of the inequality. Okay, your turn to do it. I'll just give you 1 minute to simplify it to make u be a subject of the equation. Actually, I can raise up my hand. Yeah, can you see it? Oi, I can dance. Do-do-do, do-do-do. I can also move this hand. Oi. Done. If done, then if done, then I let's go on. So u square minus g square, sorry, minus. So the answer will be u should be greater than square root g and then bracket h plus s square plus h square. So these are some results that I want you to memorize for the commission. So because you know there's so many steps to derive this result. So if you memorize the result and then when you encounter similar question, and you can use the result directly to get the full mark. Okay. They don't doubt you why you can get the answer so quickly. Okay. You can say that because you're a genius. So let's say okay. So actually there's one more question to solve. We want to find the corresponding angle. When the speed is maximum. Sorry, when the speed is minimum. Uh, so this is quite math. Uh, I'll solve it using the mathematics behind. So now when you say this is minimum, so that means you're using the equal sign here, okay? Equal sign here, equal sign. So that means it's everything is equal sign. It's not a inequality. So that means this is equal sign, and then the discriminant should also be equal sign. So that means when the discriminant equals 0, then the speed is minimum. And then when does the discriminant equal 0? You know about it? When the solution, there's only one solution, or you just say two repeated root or two repeated solution. So that means that x equal to negative b over 2a. We've thought about it before. So then we can directly use the uh, this equation, and then okay, the tangent theta equal to negative b over 2a. So what is b? B is s. A is gs squared over 2u squared. Okay. I think something like that. So the formula you get is the tangent theta equal to u square over gs. Yeah, u square over gs. You it's quite interesting, is it? Because it's independent of the h. It's independent of the. Oh no no, it's dependent of the h because the u is dependent of the h. So you need to substitute the value of u again here. Okay, use, you get the u here, and then you can simplify to be final like this. So that is your final answer for the angle theta. So you may consider this question is the most difficult question in the projectile motion, but you may also consider this is an, the only few types of the Olympic question that can be tested in the competition. So I will just talk about another type of question, and then we finish this lesson. Yeah. No, no, another few types. So let's have a look at this type. So the ball is thrown horizontally to the right from the top of a vertical cliff of the height h. A wind blow horizontally to the left, and assume the effect of the wind will give. Why my character? Okay, my. So assume the wind will give the acceleration a constant force that equal to the weight. So in this question, that means actually the ball experience two acceleration. One is the acceleration downwards due to gravity. One is the acceleration to the left that's have the magnitude as g due to the wind. So how fast the ball should be thrown such that it lands at the foot of the cliff. So that means it will move along like this path and then move at this point. So first of all, let me still let the horizontal axis and the x-axis first. So let me use another color. So let's say this is x-axis, this is the y-axis. Now you need to think about this question again because we can't use these four derived equation. This one or not this one. Because in these four derived equation, we assume that there's only one direction of the acceleration. So we need to start again from the beginning, okay? Start again from the beginning. So we start from the x equal to the ux times t plus half ax t squared. Yu equal to uy times t plus half ay t squared. Vx equal to ux plus ax times t, and then Vy equal to uy plus ay times t. Okay. This is always lacking. Okay. So in this case, this assertion you need to take it to be negative because it's opposite to the x-axis. This assertion take it to be positive. So this is the ay, and then this is the ax. And then because the initial velocity is horizontal, so that means that ux equal to u, and then uy equals 0. And then we substitute in these equations. Then we can get these formulas. Okay. Then of course we also need to substitute everything that we know about it. So we know that the vertical displacement, the displacement along the y-axis is h. So the y equal to h. And if we turn to the foot, so actually it touched the y-axis at this point. So that means that x is 0. Okay, the x is 0. Then actually we solve this question, we solve this one, we can get the time. And putting the time on this equation, then we can get the u. Then you can get your final answer. The same this one. So this is the final answer. So this is the speed for the object to land at the foot of the cliff. So this is one skill that you need to know. So even though if the assertion has two direction, you can starting from the original formula and then to derive the formula that you need. I think this is not really difficult, is it? I hope it's not really difficult. If no question, then let's move on. So let me put my hand down. Okay? Otherwise, it look weird. So let's do the next most difficult question. So you can have a look at the question first. So a ball is thrown at the angle theta with the blanket wedge. So the scenarios look like this one. This is angle phi. This is angle theta. Okay. So and then we are with the initial speed u. Okay, with the initial speed u. So find the range. So that means you're going to find this distance. Okay, find this distance, and then find the angle to give the maximum range. This is much more difficult. Okay, mathematical speaking, it's much more difficult. So let's do the part A first. Part C is much more difficult. You can have a look at it. So it collides with the wedge and then with the loss of energy, and they will rebound a few times and then go back to the initial point. So find the range first. Find the range first. So how can we do this question? There's only a assertion. There's downwards g. So the physics approach is to rotate the y-axis and x-axis a bit. So this is the y-axis, and then this is the x-axis. But by rotating the axis, you need to change the uh, the assertion is no longer along the y-axis. So assertion is downwards. You need to decompose the assertion into two components. So you can decompose the assertion into this one and this one. So this is along the y-axis. This is along the x-axis. So can you tell me what is the value of the ax and ay in terms of the g, theta, and phi? No? Are you still doing? First of all, does this angle depends on the theta? You need to think about it carefully. So the theta is the launching angle. If you launch a different angle, it doesn't change the angle between the g and y axis and x axis. So this angle only depends on the phi. It does not depend on the theta. So in this case, actually, this angle is equal to phi. You can derive it later on at home. Uh, so this is vertical line. So this angle is phi. This angle is 90 degree minus phi, and then can divide it the remaining by itself. So this equal to g cosine phi, and this equal to g sine phi. And for part A, to find the range, so similar to the last question, we're starting from the most fundamental formula, and then go to derive everything that we need. Okay, and then similar for the initial velocity. Okay, you need to also decompose it along the x-axis and the y-axis. I think it's not too difficult. The ux equal to u cosine theta, and then the uy equal to u sine theta. Is it? Ay, there's no square there. Both assertion are opposite to the x-axis and the y-axis. Okay, so therefore I put the negative sign there. Of course, you need to derive it at home by yourself later on because it's it takes time for you to understand it and derive it as fast as me. So next, you want to find the range. So that means when the point where the particle is at the farthest point from the starting point along the wedge. So so at this point, obviously, okay, you know the y equals zero. The y equals zero. So then we can substitute the y equals zero here. And then what we can do is to derive the time. We can derive the time. Remember, the time is always a king or the key for to solve the projectile motion. So this is the time. If you want to find the range, then you substitute the time in the x. Then you can solve the range. It's so complicated. Uh, I will simplify a little bit later, after I substitute in the equation. May you help me to check? So that's correct, is it? Hey, where's my pointer? Should there be a 2 in the denominator, the second one? There's no 2 in the denominator for the second one because the t square, you get 4 in the numerator and then divide by 2. So overall, there's only 2 in, in the numerator. I think that's correct. So that we finished the part A. Then let's go to the part B. The part B is really just math. If you can't do it, it's totally fine. You want to find angle theta. The angle, the only angle we can change is angle theta, and then uh, to find the angle theta such that it gives the largest range. But in this case, actually, what I can tell you, is actually it's not easy to derive it. It's not easy to derive it. uh, somewhat sometimes the students may use the differentiation or the calculus to derive it, but it's not really easy. Even if you are using differentiation, it's not easy at all. So I will using the trigonometry here. So first of all, let me simplify the equation a bit. Okay. Now the angle phi is a constant angle. This is the angle of the slope. Well, you can change it only the angle theta. Okay. So I will put the 2u squared over g cosine phi. So 2g cosine squared phi. Okay. And then it'll become like this one. Okay. So of course I can extract the sine theta from the equation. Then it look like this one. So this one, actually, there's one identity to simplify this one. So this is a double angle. I think I've talked about it. If not, I make another video for it. Okay. Then you have simplified the formula a bit. It looks less ugly, is it? So that means you have simplified it a bit. And then because you know the angle theta is a variable, it change. The angle theta change. So what I hope is that I didn't in my formula there's no two theta here. So I would like to use the what we call is the product to sum. You can search it online, product to sum. If you need to use these formulas, the product to sum, most likely they will give you the formula. So there's one formula of the product to sum. There's sine alpha times cosine beta. So that is half sine alpha plus beta minus sine beta minus alpha. And then I can substitute in the equation. A 2 can be cancelled out. So these two angles added together. And then minus uh, minus sine phi. Yep. So in this formula, okay, you can only see there's only one theta in the formula. So that means it's easier for us to determine when the range will be largest at different value of theta. So in this case, so only this thing can change in this formula because the theta is a variable. So the sine some angle, okay, no matter what angle it is, okay. So no matter what thing is inside the sine can only the largest value of the sine is only one. So that means the range is less than the u square g cosine square theta and then 1 minus sine phi. So the equality holds when the sine 2 theta plus phi equal to 1. So that is 90 degree. Okay, 90 degree. Then you can get the angle theta. So that is 45 degree minus phi over 2. Yeah, this can be the final answer for this already can be the final answer. But we can also simplify it a bit if you like. The cosine squared theta can be written as 1 minus sine squared theta. Then you know what should be simplified next. So you can also write the formula like u squared over g and then 1 plus psi phi. Okay. It depends. So let's say if this is an MC. So if you can do to this step, if you can get this step, but the answer gives you this choice, you should know that these two are equal to each other. Okay. So that is the part B. Okay, that is the part B. For part C, mm, for part C, so maybe I give you some time to do it or think about it by yourself. And but I need to give you some hint first. So we haven't talked about what is meant by elastic. So for collision, okay, if it is elastic, so let's say if the angle to hit the ground is 30 degree, and it will be bound at 30 degree, okay, with the same speed, with the same speed. So that is a collide elastically. Okay, so this is the hint I would give you. And then you try to do part C, and you most likely you need a hint. Okay, you need a hint. So you just ask me for hints. Okay, if you let's say you have think about it for 5 minutes, 10 minutes. Okay, you can't find think about anything to solve it. You ask me for the hint, and then if you like, I would also like you to try to do these questions. These questions. Don't do this one, but I would like you to. This one is really hard. You can skip it. I think the remaining may be also okay for you to do it. Maybe, maybe just maybe. Okay, I'm not sure. So you try to do it first. Okay. Next time you go on to talk about the relative motion. Relative motion. Yeah, I understand the question. The level of the question is much harder than you think. Maybe. But these are the Olympic type question. But I think I've teach you all the skill that you need, and then I'll give you all the clear steps to do the questions. So I'm not asking you to do it from zero, okay? So you get the skill, you know how to do it, what the skill. Uh, if you haven't learned it, I think it's very difficult for any student to know the skill to do the question. But I teach you the skill already, okay? I think it can make the question less difficult. So then, okay, let's make this lesson shorter, okay? You can try to do this one, the part C, and also the question here. Okay, so you try to do it, and then I will see you on Monday morning. Okay, any question? If no question, then see you on Monday night. Sorry, Monday night. Monday night. Okay, bye bye, bye bye, bye bye.